everyone, welcome to Jinghua Education. I'm Steven. In this video, we're going to talk about the Calculus 1 Derivative Tutor Part 5, finding the tangent line equations for a function. Okay, so in Part 1, 2, 3, and 4, we learned several things. In Part 1, 2, we learned what is derivative. In Part 3 and 4, we learned how to using power rule to find out the derivative of the function. Okay, so in part 5 right now we use what we have learned so far to do a question here. So before we start, think about what is the meaning of derivative. If you can answer this question to yourself, good. If you can't, go back to part 1 and part 2. Make sure you understand what is derivative. Okay, what is derivative? Derivative, I said twice already on the part 2. I say that one more times. Derivative is a function that collects every single point tangent line slope for the original functions. We have the functions here, right? This is our original functions. Okay, so we are looking for tangent line. So if you know how to find tangent line, let's do it. If you don't know, go back to grade 10, check my linear function tutorials. I will show you how to do the finding the linear equations by using slope intercept forms or slope point form, whatever. Okay, so tangent line. We looking for linear equations. We need this formula, right? Y equal to mx plus b. The m is slope, b is y-intercept. Or if you like, you can use this. It's all your choice, okay? This is slope point forms. It's up to you. So anyway, we need looking for two things. Number one, slope. Number two, a point. Okay, how do we find the slope? What is derivative do? Derivative is the tool to finding slope at any point, right? Good. So we got slope looking for. So we got the derivative of these functions. We got a gx equal to negative 16x minus the 4 square root of x, right? Good. So what is derivative of this? X squared negative 16 minus 4 2 square root of x. If you don't know what I'm doing here and how I'm getting here, make sure you go back to check part 3 and part 4, okay? Good. Right now we got our g prime. This is general equations. That functions gave me every single tangent line slope at any point. What point am I looking for? I'm looking for x equal to 4, right? We just plug 4 in here, which is negative 16 over 4 squared equal to 16, right? Minus the 4, 2 times 4, which is square root of 4, which is equal to negative 1, minus the 4 over, this is 2 times 2, which is negative 1. Another 4, which is negative 1, which is negative 2 here. So this is our slope of tangent line, okay? So our tangent line equal to y equal to negative 2x plus b, okay? So we still need a point. What is the point? Okay, when x equal to 4, we got a tangent line. Then x equal to 4, the tangent line and the curve will intercept at x equal to 4. This is x equal to 4, for example, okay? And then will intercept at this point. That means the point is on the curve at the same time it's on the line, right? We don't know it's on the line. We don't have the line yet, but we have a curve. Okay? We just simply substitute the x equal to 4 into the original functions. We got y value. Okay? So we got x value equal to 4. The y value equal to what? We put 4 into here, 16 over 4 equal to 4. Minus the 4 into here will be square root of 4 is 2. So times 2 times 4 is negative 8, which is 4 minus 8 equal to negative 4. So we got a 4 and a negative 4. Okay? So we got a point here. So we can just simply using the slope point forms. Okay? Slope point form just here, negative 2. And then x minus 4. And then y plus 4. Finished. That's slope point form. Okay, so if you don't like slope point forms, if you like me, you like the slope intercept forms, go ahead, let's do it. Do this. How do we do these things? We put the 4 into the here, right? We got negative 4 into here, equal to times negative 2 plus b. Then we got negative 8. You're moving here to the other side, which is equal to positive 4, so b equal to 4. Then you got one more times, which is equal to y equal to negative 2x plus 4, and then we finish. That is slope intercept form. Okay, there's no special requirement which form they're looking for, and then both answer is correct. That's how to using derivatives to finding the tangent line equations. Okay, I hope you learned. I hope you like my videos. If you do, please subscribe. If you have any questions, just comment below. I will answer your question in my next video. Thank you for watching.